Very good morning. Everyone, good morning, guys. I welcome you all for today's session, which is on compression members. Design of compression members. Good morning, everyone. Good morning. Good morning, Anusha. Good morning, Naveen. Good morning, Gautam. Yeah, very good morning, Manideep. Praveen, good morning. Thank you. Right, so let's join. Yeah, so today we are going to discuss one of the important structural element in steel structures, so which is a compression member. Okay, so very important. So for this, code is also very important. So without code we can't solve any problem, right? So by that I request all of you, so please have a code book with you along with your steel table. Good morning, Kavita. Good morning, Shashi. What about others? Let's join, guys. So we'll start in 3 minutes. Rajesh Bhattane, good morning, sir. Chandu Nani, good morning. Navya, good morning. Yeah. So after these compression members, we will go with beams, right? Beams, plate girders, roof trusses, and even we have to solve a few more problems on eccentrical connections. So we didn't solve them actually. Beam connected to a column where beam transfers load to the column with some eccentricity. So where that eccentrical connection is to be designed properly, right? So that kind of eccentric connection problems also will solve it. Yeah. What about others? Yeah, good morning everyone. Who else? Baji Sheikh, good morning. Mahi, good morning. What else? Let me join everyone, right? So in the meantime, what we do is we will try to answer this question because it was came yesterday in the Facebook. When I have seen the comments for this particular question, almost 70% of the students have answered right, but few of didn't. So I thought few people should know the answer for this. So for that reason I am showing this. So please try to look at this and try to answer this question. So this is your question. Sorry. Yeah, this is your question. Which man carries more weight? See here, two guys. So I'm asking you, which man carries more weight? So there are two persons. The first person is A and the second person is B. See, by looking at this, can you please answer me which man carries more weight? If he is A, so tell me A. If he is B, so tell me B. So if equal, so answer will be C, right? So tell me which will be the answer, A, B or C. Please look at this. Which person carries more weight? See, we can answer these questions in two ways. See, one is a common sense. The second one is in terms of solving with our engineering knowledge. Okay. See, I want you people first to use the common sense, and second I want you people to use your engineering knowledge to answer this. So if you are started answering, so the man A is carrying more weight. So they are answering A. So I want everyone to be answered. See, by looking at this, so please try to answer for this question. Which man carries more weight? See, first use your common sense to answer this. And the second way, see, play knowledge, that means engineering knowledge, to to justify your answer. Okay. So I want everyone to answer this question. So there are two persons who are carrying a weight. I want which man carries more weight. So let others join. So in the meantime, we will answer this question. Start answering, guys. Only 3 answered as A, and I want others to be answered also. Yeah, Praveen changed his answer from A to B. Okay, let's see which will be the answer. Common sense answer is B, but technically A. What, Praveen? Okay, Anusha Reddy B. Okay, I want everyone to be answered. Okay, so please try to answer. So for 2 minutes, we'll go with our compression members. So this is the question which came yesterday in our Facebook. So around 300 to 400 people answered this question, out of which almost 80% answered right and 20% students made a mistake. So here I want to give justification for this answer, and people, those who doesn't know the answer also, they can have a glance over here. And Kavita answering as B. Okay. Right. What about others? No one is answering. So I want everyone to interact with me, guys. So if you try to interact, then I will come up with plenty questions like this. So these are all practical questions which are very, very important as you are dealing with, civil engineering. Civil engineering always come up with like these kind of practical questions. Okay. Mohit Malaha, what's your answer? Okay, so let's see the answer. Comments, by using some common sense, you can answer either A or B, but how you have to justify? See, you have to justify your answer only based on your engineering knowledge. Okay, so here I will give answer for this question. See, as the person, there are two persons. One person A and the other person B, isn't it? So here the weight is almost near to the person B. So let us take the weight as 100 kilonewton, whatever the weight you can take. And the distance from A to the load point is, let's take it as 3 meters. And the distance from load point to B, take it as 2 meters. Okay. And the overall distance from here to here is almost, so which is 5 meters, isn't it? Right? See, treat this like the problems what you already solved, like, simply supported beam. subjected to eccentrical load. Okay, this is how you need to consider the problem. Like this, W, right? And the distance is 3 meters, 2 meters, and the whole span is 5 meters. What is the reaction at A? Which is W, B by L. What is reaction at B? W, A by L. So where A is equal to 3 meters, B is equal to 2 meters, right? And what will be this? 100 into 2 by L, which is, L means 5 meters. 100 into 3 by 5, which is 60 kilonewton, isn't it? So then, which person is carrying more weight? Which person is carrying more weight? Person B. Person B is carrying more weight. So this is based on the common sense you can answer, and this is based on your engineering knowledge. This is the technical knowledge what a civil engineer requires. Okay, got it? Fine, guys. See, the question is so simple. Again, Mohit is asking the question, which person is carrying more weight? Is the person A or B? So based on the picture, right? So this is how you need to answer questions. So even in interviews, people are expecting you to deal the practical problems with your engineering knowledge. Okay, that is what a practical civil engineer really need, okay, for his job, right? So we don't want any person who mug up all the concepts, who mug up the formulas, okay, who mug up the engineering fundamentals. It should really be in your mind. Okay, so that is what exactly the companies need from you guys. Okay, so please try to practice all engineering fundamentals in this way. Everything relate your concepts with the practical things. So then only you can able to remember everything. Okay, right. So now we will move on to our concept, which is a compression members. Okay, so let's start with compression members, right? See how you define a compression member. See, basically many structural members are in compression, isn't it? So if you take any civil engineering structures, so obviously many structural members will have a compression member. So a vertical compression member in buildings, we call it as a, in buildings, a vertical compression member, we call it as a column, isn't it? So by that, column is a compression member. In electrical posts, in electrical, we call it as a vertical member, which is called as a post, right? And the third one, in bridges, the vertical member, we call it as a stanchion. Sorry guys, my pen was not working. It's not writing, so let me write with the pencil. Right. See, the vertical is called a stanchion. It can also be called as a pier. Okay, pier. And the fourth one, in trusses, so it won't be a vertical member, it will be an inclined member, so we call it as a strut. Okay, in crane, a jib of crane, so which is again an inclined member, so we call it as a boom. See, these are all compression members, right? So in buildings, the vertical member, we call it as a column. In electrical posts, in electrical, street lights, the vertical member, we call it as a post. In bridges, the vertical member, we call it as a stanchion or a pier. In trusses, the inclined member, we call it as a strut. And in the jib of the crane, which is an inclined member, we call it as a boom. So these all are what? Compression members. Okay, so these are the real applications. So you have to remember, isn't it? So these are the compression members. See, a compression member is a structural member which is always straight or inclined and subjected to two equal and opposite forces. So let us take a member, so which is subjected to two opposite compression forces which is applied at its ends. So this is end, right? Okay. So which is perfectly straight. Obviously, even if you take an inclined member is also straight, where the forces are in opposite direction, again which is acting at ends only. Right? So this is straight or vertical, we can call it as. So this is also straight but inclined. Okay, there is a difference, guys. Straight, vertical, straight, inclined. Okay, so that is how we define a column, right? See, an ideal compression column. So here's my other pen. 1 second. Let me write with red pen if it is the case. Yeah. Right. See, an ideal compression member is the one which is perfectly straight, without any crookedness, without any imperfections. Then the loads are applied uniformly across it. Right. So without having any crookedness, no crookedness in the member, no imperfections in the member. So by that we can call this member as an ideal column and pilustam manam. So this member is called as an ideal column, right? Without having any crookedness, without having any imperfections. So then what happens? So this is where the load is applied uniformly across its cross section, right? So let us take this a cross section. At this cross section, the load will distribute uniformly, right? So with the center of gravity of the load, which coincides with the center of gravity of the member. So let us take this the center of gravity of the load, which always transfers loads to the center of gravity of the section, right? Center of gravity of the load transfers to the center of gravity of the section, isn't it? So that kind of compression members, we call it as a column, right? But however, so this is called ideal column or a true column. Truly axial loaded member under. Truly axial loaded member. Okay, got it? An ideal column, or it can also be called as truly axial loaded member. So what is the meaning of crookedness? Crookedness in the sense, member which was, without any rough in nature. Crookedness and bends lekunda straight ga unna member anamata. Okay, understood? So crookedness in the sense where the member is straight without having any bends in between. If the member was manufactured, let's see this is the cross section. Let's see this is the member. So where the member was straight without any crookedness, without any roughness on the section. Okay, so that kind of members are called no crookedness and no imperfections in the members. So ilanti members ni we call it as a true ideal column or truly axial loaded column. Eppudaithe member kodiga bend ayyi, okay, kodiga rough ga undanukondi, then what happens? You might not say that column is an ideal column. Okay, where? Because the load won't transfer axially into the member. Okay, so by that, from end to end, your cross section should be same. From it starting from end to other end, your cross section should be same without any imperfections. So that column is an ideal column. Okay, right. But see the real situation. However, the situations as stated above are impossible to achieve. Do you think this is possible? So this in practical, this is impossible to achieve a perfectly axial loaded column member will ever be encountered in practice. See, in practice, you can't expect that load should transfer axially from one end to other end. So in practical, it is impossible. Why impossible? Because your column is not just an ideal column. Your column may connect with the different beams. Your column may connect with beam on the top. Your column connects again on the top. There will be a slab. So like that all loads should transfer to the column, and by that your column should transfer load exactly through its center of gravity. So do you think that is practically possible? No. So practically that is impossible. So that is how engineers always take that as a challenge. They will maximum try to transfer load centrally into the section. So but whatever care taken by the engineers enta care తీసుకున్నా to transfer load axially where unexpected eccentricity of load is unavoidable. Okay, engineers enta care తీసుకున్నా, even though engineer take care, so there will be unexpected eccentricity of load is unavoidable due to what? Due to imperfection. Okay, due to imperfection. So this is what practically happening. So when a designer designs a section, he always designs a member to transfer load vertically through its axis. But practically what happens in engineering practice, the unexpected eccentricity falls in the load. So why? Because your column should carry a beam load, isn't it? So when the beams are placed in longitudinally, so that force will transfer to the column with some eccentricity, isn't it? So in that eccentricity, definitely there is a chance of eccentrical load, which makes member to have a buckling characteristics, to have a lateral buckling. So unexpected eccentricity of load may happen, which makes member imperfection. This eccentricity causes, what this eccentricity causes? This eccentricity leads to bending moment, okay, which results in what? Bending compression. Okay, apart from an axial load, due to unexpected eccentricity of the load, which leads to bending moment in the column, and again this bending moment leads to what? Leads to what? Bending compression in the member. Okay, so got it? So that is how axial compression members increases the lateral deflection. So by that, when your axial load in the column is more, obviously the lateral deflection also increases, resulting into the additional bending stress. So that you need to, okay, make a note. Understood? So apart from the axial load, the unexpected eccentrical loads creates a bending moment, and it creates a bending compression in the column. So by that, when axial compression increases, when axial compression increases, what happens? Lateral deflection also increases. Why? When axial compression increases, lateral deflection increases? Because of the eccentrical load, because of the unexpected eccentrical load, which increases the lateral deflection. So which also results in, resulting in what? Resulting additional bending stress. Okay, if engineer, if he makes columns to transfer load axially from top to bottom of the whole building, so he will be a perfect engineer. But practically it is impossible. It is not just I am telling a small possibility, right? It is impossible. Why? Because your load in the structure won't be always vertical, right? Your load won't be always axial. So there will be a lateral forces, there will be an eccentrical forces, there will be a lateral forces in terms of wind, in terms of earthquakes, right? So these all forces combined together should transfer into the column axially. Do you think is that possible? No. So that is impossible. So that's the reason why. So when the axial compression increases, automatically the lateral deflection also increases in the column, which leads to resulting in additional bending stresses. So that is the reason why in steel structures, we design column not only for the axial load, we design column for not only for the axial load, we design column for bending stresses. అర్థమవుతుందా? So this is what happens in the steel column. Not only in the steel column, even in your RCC also, you can't design your column just for an axial load. Okay, so there is a possibility of buckling ante bending valle kada buckling jarutundi. So that is how. So due to this eccentrical force in the column, so when there is some eccentrical force, instead of just compression, there will be a bending takes place in the column. Okay, so there will be a slight deflection in the column. So this is called buckling. Which buckling? Lateral buckling or lateral bending anta. Okay, this is what happening due to eccentrical load. Okay, due to eccentrical load, this is what happens, right? So that is the reason why when you are designing a column, so we should design not only for the axial load, we should design by keeping bending in mind, right? Understood? So this is the important information about the column, right? And the other important property in a column is a slenderness ratio. Chala important amma slenderness ratio. I think sorry guys, my pen was not working right now.